Hey everyone, and welcome back to the Noodle beginner tutorial series. In this episode, what we're going to look at is how to make our app the most efficient possible with relation to querying data from its backend. So, just to get started, and I'll try to make it as quick as possible and not ramble, but I wanted to give a little history about how I came across these very basic fundamental coding principles for the development principles, let's say, that are used by people who already for a long time by people who code their own front ends and back ends. The concept is that your backend requires, so calling out to a backend, making a query like this to a backend, it costs a little bit of network. I'm not going too much into detail, but when we load our page, we will get, if it stays open, there we go. So when we load our page, we'll get, if you look into your browser tools or go into the tools in Noodle, so this is just for your own experience and a little bit of fun, you can go and have a look at where there are requests being made to the backend. So here there's a request that was made for tasks, and you can see the response. There's no results or whatever. This one had some results. And what we see from that is the amount of time that it took to make that request. So it took 24 milliseconds, super fast. And that's because it's just making a request to the local host. As you can see, when you open up the task call and you go to the request URL, you can see that it's localhost 3000. So that's incredibly fast when it's calling something that's on your local computer and you wouldn't even notice. So you could be developing away, putting queries all over the place and thinking, this is great, my app has got automatic data coming through, I don't have to manage data consistency or persistence. I can just keep putting queries down and just have the data always updated because the query continually runs every time the data changes. The problem is that when you get into production, the 24 milliseconds will change into 100 milliseconds, maybe something like that. It depends where your backend is hosted, because then at that point, your backend will go, the database on backend will go to AWS or Google Cloud platform or your own server, but it will be in a somewhere in a data center somewhere that's not in your house. So it has to go through the pipes and get to the backend and come back again. And so you're up to something like 100 milliseconds, say, for example, for a backend call. And so here we've just started our task app and we've already got 2 queries. If I keep dropping queries everywhere when I want to have the tasks fed into something, say, for example, I want a task pop up where it opens up and I see the details of the task, then I'm going to have a record node there. Maybe it'll also do a fetch instead of just working on things in the front end, or I'll query and filter or something like that. Then these start to multiply. And so when you load the page for the first time, maybe you might have 2, 3, 4 queries all running at the same time. And they're all going to take 24 milliseconds, 100 milliseconds, and they're all going to run sequentially. They're not going to run synchronously. So in the end, you're going to have 500 milliseconds, half a second of queries. That's on top of loading all the other stuff in your page. So loading the font files and loading the basic Noodle files, the runtime that's required to change what you've made in the editor into a React front-end web page. So all of these things add up, and it means that when your user's clicking on something, they might have half a second to wait before they see the result. And if all of your users are clicking on these things and they're all having half a second to wait, but there's also a lot of people making requests to the backend. So your backend starts to get stressed out. And in AWS or Google Cloud Platform, that doesn't matter because they'll just scale it up for you. So they have a system where if you have 1,000 users all asking for their tasks all of a sudden, then Google Cloud Platform will spin up a whole bunch of new backends for you to cover the physical cost, the actual machine cost of having to respond to all these backends using the RAM and the CPU of the backend, the hosted backend, and you'll end up paying for it. So this is where people get these big legendary AWS bills or Google Cloud Platform bills for thousands of dollars because they didn't manage their data queries very well. So all of that to say, there's a whole bunch of reasons why we should not just abuse the backend. The general principle and best practice is to try to use your backend as little as is possible, i.e. if you don't need to make the call, don't make the call. If you can work with data on the front end, then work with it on the front end. Work with it in the local, where is it? The local storage. So work with your local storage or session storage. Most often it's session storage that's used for stuff like this. I'm not going to go into it because I don't actually understand it, but the way that Chrome or any other browser stores data inside the browser when it's queried, and then can use it from within the browser to manipulate, to change it, to supply it to other elements. The app can call the browser storage and say, hey, give me those tasks that you were storing there. I need to use them for something. So we don't need to be reaching out to the backend every time we need to use a task. And this is a fundamental principle for development, but something that I didn't know because my first 6 years, 7 years in development were with Bubble or WordPress, but particularly Bubble, where and with WordPress too, you know that there's a backend, you know that there's a database, but you don't see how Bubble operates in terms of queries. So if I have a page in Bubble and I have, say 20 lines in a repeating group, 20 tasks, and each one of those tasks is making some sort of query and filtering in the back end saying, get the task unless the task is complete and then get this instead or something, then Bubble handles that automatically. It says, okay, I can see that there's a query and I can see that query is repeated 20 times. I'm not going to make the query 20 times. On the inside, in the background, the man behind the curtain of Bubble is storing one of the queries in session storage and then using that same query for the other ones to try to optimize the amount of queries being made. So using do a search for in Bubble will not always do a query. And so I got used to just putting queries everywhere, and 100 queries or more in one page. Why not? Because Bubble handles it all very, very well and automatically. And that's just not normal. That's a no-code tool. What we're using here is a low-code tool where Noodle is not going to do these kind of things for you because it's based on, in the background, it's based on JavaScript. It's not running some magic tool that's going to stop from making 100 queries. If you put 100 queries on a page, you're going to open up your network window and you're going to see 100 queries, each one of them with 100 milliseconds. And so you're going to be on 10 seconds to get your website to respond. And that's not good. We can all agree. So that's what we're trying to do today, is to shake off the Bubble or no coding world of everything is managed for you and try to understand how we can manage data in the front end using the browser storage. You don't have to learn about browser storage. You just have to use these best practices that will get your data stored in the right way. What I'm going to show you in the tutorial today, as a disclaimer, is not by any means the only way to do what I'm about to do. The way that I'm going to show you to store data is pretty standard, but you could do it with functions as well, and you could make your own arrays, and you don't have to use the Noodle nodes for this. I like using the Noodle nodes because it helps automate a lot more things for me that I don't have to code. So, if you're coming from a no-code background like me, you're coming from a world where you prefer not to code things. So if we're on the same page there, I think you'll appreciate this. And also the way that data changes are passed through different components to where they need to go is not, the way I'm going to show you is not the only way to do it. It's the easy way to show you in a simple way how to get your app started, but it is by far the only way. You could use event signals. You could be sending events from one component to another. You could use component objects and parent component objects to pass data up the chain, up the document object model to get to where you need it to go, and down again if necessary. So there's lots of different ways to do it. I've got other videos about how to use component objects. I've got other videos about how to use events and I've got a video about MQTT, sending MQTT events to webhooks or whatever, WebSocket connections that can also send automatic messages from one component to another, and to other users as well who are using the app currently, so everybody sees the data appear live, and etc, etc, etc. But what we're going to use today is just the simplest way. So I'm not saying this is the best way. I'm just saying it works. And that's what this tutorial series is all about, doing the beginner things that work. So that's my rant over. We're going to get into the tutorial document, which I hope you have open in front of you. Once again, written by my partner, Carolina, whose link is at the top of the document as well, if you want to get in touch with her. So we've opened our task list app. We know that our Docker is running. It says it's running, and I can go in and have a look, and there's my backend is running, or whatever your backend is. Just make sure your backend is spun up, or else the queries won't work. We're going to go into our start page, and we're going to have a look at our query node. What's happening at the moment that I explained last time, the query node is running automatically because it has no do signal attached to it. When it has a do signal, it's kind of like it's a function and it's being called by something. If it doesn't have a do signal attached to it, it's like a function that's just there and it just runs every time the page mounts. So we want to actually have that run only in the case that the page mounts. We want it to run once. We load the page, collect our data, and then that's it. We don't want it to run again unless we tell it to. So we're going to say that when the page mounts, which is essentially saying, remember that pages are not like start page.html. It's not stored somewhere like that. This is React. So we have the physical page is index.html. This page, start page, is part of this internal system of components of React. And so we need to say that when it mounted, which means when all of the components inside it have been built and it becomes visible to the user in the browser, then we want to do the task query, so that whenever the page itself and all its contents are built and it's going to be visible to the user at that point, then we do the query and we get the items into our repeater. So we can refresh the page just to make sure that works. And you can see that the did mount triggered and the items were queried and put into the repeater. So that's perfect. Now we need to take those items and store them somewhere, store them in the browser, in this magical secret land of the browser session storage. So we need to get into our node picker and take an array node, put it under the task node. We're going to call it all tasks. So it's not just the node name, it's also the identifier for this array. This array is essentially a variable in JavaScript. So we've declared all tasks is equal to, and at the moment it's equal to empty. So you can see this little array symbol here. It's just empty. It's just an empty array. The square brackets is an empty array. And an array is just a collection of objects. And objects in JavaScript are like what you see in JSON. If you've done API calls, you'll see curly braces, curly brackets. And inside that, there'll be something like name, double point, Richard, email, double point, whatever. Those are objects. And if you have lots of them, like the next one is name, double point, Carolina, email, double point, whatever, then that's an array of objects. That's 2 objects in that array. At the moment, there are 0. So that's all this is, just a variable. But a variable we can call from anywhere inside our Noodle app, and a variable that, because it's declared as an array no-code node of Noodle, it makes it easier to work with it within our node canvas. It's going to provide us with signals like the array has changed, or I can push something into the array and then say that it's changed, and that's way easier to program in this no-code fashion and with this visual programming fashion. Anyway, take your task query node all tasks connection and connect the items of the query to the items of the array. Now our lovely array looks exactly the same as the array we got back from our API call to the backend. Except that this array is not going to ever call the backend. It's going to just use the data that it has here and let us manipulate that wherever we want in the browser. Every time we reference this, it's not going to create anything new. It's going to use the data that's already there. So we're minimizing the amount of kilobytes or bytes, actual physical data that we're using inside the browser or storing inside the browser. And we're minimizing the time that it takes to get this array viewed by the user. If I put this array somewhere else, it's immediately going to come up because it doesn't have to call anything. It's already inside the browser. It's in the user's computer. So like I showed you that when we did the call to the local host, it was 20 milliseconds. Well, that's because it's in the same computer. So it's almost instantaneous. And so that's what this array represents, is instantaneous access to your data, which is very nice. So we've put the inputs in there. We're going to disconnect the items connection to the repeater. We don't want this to supply items anymore. We want this array to supply items to everywhere we need. So we're going to connect items from the array to items of the repeater. We can refresh the page and it's perfect. The array items are going in and the repeater is receiving the same items as before. So we've connected that up, and now we're going to try to do something. We're going to add a task. So let's add a test task. Oh, but look, it's not there. And it's like this. I'm really bad at theatrics. Sorry. So the 2 items, query 2 items, in our backend task 3 items. You might need to refresh. You'll see 3 items in your backend. So there's the test task there. So why is it not there? Well, what if we refresh the page? Oh, there it is. Because the query is only running every time the page mounts. Just because I add something doesn't mean that the query runs again. It's only connected to the mount signal of the page element, the page component. So adding a task doesn't change the query. It doesn't change the array. This is all stored locally. We've sent the task to the backend. That's still working. And this is going to 2 because our header is still connected to the query node with no signal. It's the second query that's running. But we do not have it being received here on the front end because we haven't set up anything to change what is visible on the front end. So we'll have to do something about that. So we're going to go into the add task component, either through here or double clicking it here. At the moment we have a create new record node, but that's just to send a signal going out to the backend. Nothing is coming back from that except for okay, done, right? So we need to do that manually on the front end. And this is what's known as having synchronization between your backend data and your front end data. Having this kind of data consistency or data permanence or persistence or something like that. Is to say I want to have a mirror image of what's in my database and in my front end at all times, but I don't want to achieve that by always doing calls to the backend. If I've sent a task to the backend, I know that it's in the backend. I can just put it in the front end as an object. I don't need to have it come back from the backend. I know what I just sent. So I can create that mirror image here, send it to the backend, and use the mirror image in the front end by adding it into the array. So we're going to add an insert object into array node. This is essentially like the JavaScript push command. So we're going to name it all tasks. No, what? We're going to name it insert new task into all tasks. I prefer that. We're going to connect the task create node to the insert node. When the task is sent to the backend, we're going to do this insert. And we're going to connect the ID of the task that was just created to the object that is supposed to be inserted into the array. Now all that remains is to tell it which array we want to insert it into. And when you click on array ID, because you're using the Noodle array nodes, like I said earlier, it makes everything easier. These are declared as global variables throughout your whole app. So anywhere you place anything to do with an array, this list of available declared global variables will appear. So we can click on all tasks. And that's it. So it's going to insert the newly created object into the all tasks array. You don't have to click it here. You could also have fed that name of the array into the node through an input, but we don't need to do that. So that's all we need to do for that. And if we refresh there to get all of our tasks, if I now add a new task that will be inserted into the array, it's here. Now look what happens on the start page. The all tasks array has a count of 5, and the one we've just created is the fifth, because it always starts at 0, the 5th object. The query node only has 4, because the query node has not run again. It's still got how many tasks we asked it for at page load, but that doesn't matter because we fed those 4 tasks in, and then all the manipulation we're doing from now on, inserting, deleting, etc., is all going to happen through the array. But that's okay, because if I refresh the page, I know that the data in the back end is the same as the data that I had in the front end. So even though you could be fooled into thinking that something's wrong, it's not. It's really just that we don't need to do that query 100 times. Every time the user adds a new task, we do a query. That would be a lot of queries within one session for that user, and a lot of stress on your server if you have a lot of users using that session. But now we cannot delete tasks. Look what happens when we delete tasks. So there, it's correctly updated in the header, which is still doing the queries spontaneously, that a test task has been deleted. And also, just another little point about that, if we go into our task item, look what happens to the delete record when I'm like, oh, it didn't work, I'll delete it again. And then that fails and says object not found. It's because in the front end, the array has still that object. It doesn't disappear just because I deleted it in the back end. And when I try to delete it again, this call to the back end says, no, well, that object doesn't exist anymore. And I'm like, yes, it does. I can see it right here. Yeah, because I've got a mirror copy of it in the front end. It's not because it exists in the back end that I see it here. If I refresh the page, a test task is gone because it's done a new query and said, oh, there's actually just 4 tasks. So I'll query those 4 tasks. So we're going to have to do a remove object from array node. This is the equivalent of JavaScript splice, which will find an object in an array and then slice it out at that particular point. So it deletes it from the array. Not pop, which is when it takes it off the end of the array, which is not what we're doing here. What we're doing here is specifying that when something is deleted, it's going to find the ID of the object. So we're going to take the task record ID. It's going to find that ID in the array all tasks, and it's going to slice it out. So then we'll have it deleted in the back end, and we'll have it sliced out of our array in the front end. So we've connected that up with a success signal. And now if we test it out, we're going to see that send task to or another one, let's do another one, disappears. So it's deleted from the back end, and then it's taken out of the array with that ID. So that copy, that ghost copy ID has been removed from the array, as well as the same ID which has been removed from the back end. Remember that the IDs that are in the array, the all tasks array, are exactly the same IDs as the ones that are in the back end. So that's how we have this mirror ghost image of the data in the front end, is that the ID is the same. So we can always play with that fact that it's the same ID in the front end as in the back end. We only need one ID to be able to delete that. Okay, so we've done that. Now what we're seeing is that when we delete a task, the header doesn't change because it's still doing, if we delete here, for example, oh, it does change, the header does change. But we need to have it connected up in a way that it doesn't do a query, that it only uses the array to find out how many tasks there are. We've got one query here, we don't need to have another query here. That's just redundant. So let's go into the header component, and we're going to replace this task component, this query component, with an array node. So there's no array at the moment. I have to go up here and specify that it's this one, this declared all tasks global variable. I have my 2 arrays there. We're going to remove this one. We're going to use, we can't just connect it up because the array itself is just the raw array of data. It's all of the results. Whereas with the query before, if you remember, we were filtering to only have the tasks that were done and then using the count of tasks that are, not done. We were using the count of tasks that are not done to say how many tasks are left to do. So we have to have that same filter for all tasks. Now again, there are better ways to do this. You can use a function node. You can write your own array filter. It's very quick and easy. But let's just do it the no-code way so we learn how to use these nodes, which works just as well, not as powerfully, but just as well for these kind of simple situations. So we'll add an array filter. And you get the same sort of thing here as what we had in the query, except that we don't get a handy list of all of the different fields that we could possibly use, like we did with the query node. When we do a filter here, we have to specify, it's not very well explained in Noodle, I have to admit. I'll explain how it works. When you create a filter, you're specifying the exact name of the field from the items of the array that you want to filter out. So we said before it was the done field. So we have to type it exactly case sensitive the way it is in the object. If you're in doubt, click the object and have a look for the field name, which is done. So that's what we have to have here. And the done filter is going to be either a text, a number, or a Boolean, a true false. So we want to get only the values where the true false done is equal to false. There's a little there's a little Noodle bug here, which is that if you don't select, if you just leave it like this, as it's been freshly created, it doesn't understand that this is false. It just leaves it blank. So you need to kind of activate it and deactivate it to make it false. So check it like true and uncheck it, it'll become false. It's just a bug that you need to live with, or maybe it's already been fixed and you're watching this in the future and it's already great. So we're going to connect our all tasks items to the items of the filter. So it goes through the filter. It tries to check any of them that are actually done false, which is what we asked it to do. And then we can take the count of the filter and put it into the text of the number of tasks left. So that's great. So the count only runs on page load at the moment is one of the next problems that we have. So we have the correct count, that's great. If I add a new task, it should go to 2. Oh, it does go to 2. How did that happen? Oh, it's filtering the count again. Perfect. Oh, because we were connecting it up to, oh, I think we connected the header. What was it said in the, okay, no, we don't actually need to do anything else because we don't need to connect to the filter to make it run. Perfect. So actually that bit is not necessary. Oh yeah, there we go. That was what it was. I was saying to myself, that's actually okay. We can just leave it there because when we add things and delete things, it gets updated. But actually what the tutorial was all about was that when we change a task from true to false, or from false to true, this doesn't update. So sorry, let's do that again. Sorry for that little pause and mental breakdown there. We'll add a new task. The array changes, so the array filter happily takes the new data. As items go into an array filter, it fires it automatically. So we get the new task, and as we delete a task, that also fires it. You can see it loading up, lighting up there as it goes. But if we add a not done task and turn it into a done task, then it doesn't update. So why is that happening? I remember having this moment when we were making the tutorial and thinking, oh, why is that happening? Oh yeah, because when the array changes, like the items change, and the items input detects a change in these no-code nodes, they fire. Unless there's a signal hooked up. If you had a signal hooked up, that's why I was confused. I was thinking, was it the did mount needed to be hooked up to filter? No, because if the items change, then the filter runs. The problem is that that change is only when the array changes. Now, if an object changes from false to true, that doesn't trigger the filter, because the filter says, yeah, you've still got two objects. It's great, the same as before. It doesn't look inside the objects and say, oh, I see that some part of an object has changed. Just have to think of it like really clinically and literally like that. The array has not changed. An object of the array has changed. Imagine this object had a sub-object, like a nested object. Well, would the array change if the nested object of an object changes? No, it's the nested object that changes, not the object itself. So that's kind of how to imagine this. Anyway, all of that aside, what the heck are we supposed to do? How are we supposed to tell this filter to run when something in the array, inside the array, changes? Well, there's no native way to do that in Noodle. We can't say when one of your objects changes, do something. You know, you have a changed signal, but again, that's only running when the array as a whole has changed and not one object inside the array has changed. So we're going to go into the next part, which is importing and exporting the Noodle way. So this is about a concept in React, which I think Carolina has left a sticker about somewhere. Yeah, up at the top. Was it this one? Yeah, up at the top where she talks about mounting. It explains a bit about how components work in React. And what we're doing here is we're trying to take an event that's happening inside a component and pass that event through other components to get to here. What we want is that this filter is told to run whenever something changes inside this item of the repeater. So this is where we're getting a little bit complicated, but we're going to get there. So first we're going to add a component input to our header. A component input says, outside of my component, when you place me somewhere, I'm going to have some ports that you can put data into, or you can put a signal into. So we're going to go to the plus icon at the bottom left here to add a new port, and we're going to call the port task item changed. So when a task item is changed, we're going to feed something in here, and we're going to connect that up to the filter node's filter. Now, normally a signal is blue, but a component input doesn't know, because it doesn't make a difference between signals and data. So this could be the ID of the task item, it could be a signal, it doesn't know because there's no specification. We don't make a difference between signals and data. So if a signal comes into here, it will still run like a signal, even though it's not blue. So there's nothing to worry about. Sometimes they will change to blue when something blue is attached on the outside, sometimes not. It just depends. It's a little funny Noodle thing, but there's nothing to worry about. Just because it's yellow or orange doesn't mean that it's not going to fire a signal. So we want to get this connected up to here, so that when I click here, a signal fires out up into the header and comes down here into the filter. And like I said, you can use that with component inputs. You can do that with events and things. There's other ways to do it, but this is just the most straightforward, easy, no code way to show you how to do this. So let's go into the task item. So it's this that we want to be firing the signal all the way up to the header. So we're going to add a component output to this. And the component output port is going to be called task item changed. You can call it whatever you want. And now we're going to connect up the success signal from this node to the output. Then that means that when this is fired, you can see a signal going out of the task item. It's not the end of the story. Now we have to go to the, oh, and there's another one as well. We can also hook up the delete record to the component output. It's not necessary here because we actually have already, the array is already automatically updating, but we're going to have a little bit of an issue later where, because we're connecting a specific input to the filter to say that it should only filter when a signal is fired, it's no longer going to auto fire. So just because we delete something, it's not going to automatically change the array anymore. It's not going to automatically filter anymore. And so even though the array has changed, because it's got this do signal, this filter signal hooked up to it, it will only fire when that signal is fired and not just because the items have changed. So we need to hook this up, or else we were not going to get the count updating, the filter running when we delete an item. So that's important. And anything else? Yeah, and the add task component, we need to do the same thing, because if we add a task, the items of the array are going to change, but the filter will not run unless the signal is fired. So we need to have the same thing here. Component outputs. Task added, we can call that. And we can hook up the create record or the insert new task record, whichever one you want, done to task added. So when the process is done, it fires off this signal. Now we have to go back to the start page. What we have now is an add task element, a repeater element that are both giving outputs, and we have a header that's waiting for an input. So we need to connect the add task node to the header node, and you can see the things that we've created there. The output of add task added can be put to the input signal of the header task item change, and it even shows me it's a signal because it's connected to a signal input inside the header. So connect that up. So now when a task is added, it flows into the header. And also from the repeater, when a task item is changed in one of the cells that's fired, then we need to say that a task item is changed in the header as well. Perfect. So the header is told to react within a session. It doesn't automatically run anymore. So we're going to need to go back into the header, because if you look, when we add a task, it's going to update it. There. So it's now updating every time we add a task, but it's not going to run when we load the page. It's at 0. It'll run if I do something, because the signal fires and that causes it to do the filter. Otherwise, when I load the page, no signal reaches the filter, so it doesn't do anything. And so the final thing to do is tell it when the header is visible, when it's mounted, then it also should do a filter. So it should do an initial filter when the page is loaded. That's one signal. Then it should do however many filters it takes, depending on the number of things that are clicked. So let's make sure that that works. So when it mounts, it runs the signal. This one does not run. This one has run. Now if I change something, it filters. So you can see that the task item change lit up, and it did indeed fire the signal. And if I delete, it also fires the signal. So that's it. That is perfect. Now we have our one query. If you look at your start page and we do a look here, page refresh. So now we have one task call. And if I add things, it does a call to the backend to post that task to the backend database, but it doesn't do another query to get the task back again, or two queries possibly, because we had the two query nodes before. So we've absolutely optimized as much as we can the way that we communicate between the front end and the back end. And so this is great. If you wanted to do further steps of optimization, because I just said we've optimized as much as we can, it's not true. You could theoretically store new tasks in bulk in session storage and say, okay, don't even send the tasks to the backend, add them in the local storage or session storage of the browser, and then when the user clicks save or when the user leaves or something, then send the 10 tasks that he or she created into the backend. So there's only one call sending 10 tasks, and that's way more efficient than doing 10 calls sending one task at a time. Sure, that's what I'm saying. This is, you get into now this kind of developer debate of what would be the most efficient. But I think the way we've run it here is pretty efficient, and it shows nicely how we can store data and how we can pass signals around to be able to manipulate that data and make sure that everything runs not automatically, but just runs when it's supposed to. And you know which order things are supposed to run in. So this is definitely an efficient, in my opinion, way to use data in the front end and not make as few calls to the back end as possible. Just a little note at the end of the tutorial is that these things that we're doing, like having the changed signal, for example, if we had the change signal hooked up the filter, because we want to make sure that when we add something or delete something, that the task array changing fires the filter. These kind of things work better when they are used in conjunction with something like the insert tasks into array, insert object into array node. Arrays themselves by nature don't have a kind of event listener. So this changed function works because the way that Noodle has set up these no-code nodes means that when the insert object node fires or when the remove object node fires, the array node is listening for those other nodes. So those nodes are actually connected in terms of their signalization. Whereas if it was something you've just created in a function, you wouldn't have the same automatic signal firing when the array has changed that will fire out and do something. You would have to design that yourself. You would have to add an event listener to the array, and that is absolutely possible. And I think even in the Noodle guide, there are ways to create an array as noodle.arrays in the function in JavaScript, and then actually add an event listener to that array and have that fire an event when the array is changed. So there are ways of doing it, but if you want to do it this way, the easy way is just to mention that this change signal is not a given. It's something that works with the other nodes that work in Noodle or with the Noodle methods like adding event listeners. So if you're just using pure vanilla JavaScript, you're going to have to write your own event listeners and have to create your own system to fire signals when things are changed. So using the nodes this way and sticking with the Noodle stuff, it can make things easier for someone who's not comfortable with scripting everything in JavaScript themselves. So it was just something to mention because I was tearing my hair out before, wondering why the change signal is not firing even though I'm running a function that's changing the array. And it was actually just because it's not part of the whole Noodle array system. It was me working with arrays in JavaScript without the Noodle system. So it's really kind of one or the other. If you want to mix them up, that's where you can run into some really head-scratching moments. So just be careful about that. And I hope that will help you to avoid some disappointments. So that is the end, I think, at the moment of our task list creation app series. We've set up an app that is nicely laid out and efficient data-wise and pretty fast for users. And so I think we can all be pretty happy with that. And I look forward to seeing you in future videos. Thanks for watching.